Our star, the sun, is a giver of life. It bathes our planet in warmth and light. Without it, Earth would be a frozen, barren rock. Yet, this familiar celestial body holds immense power. Sometimes that power is unleashed in violent outbursts. Scientists are now issuing urgent warnings. They speak of a coming solar storm, one of significant magnitude. Our modern technological society is surprisingly fragile. We depend on systems vulnerable to the sun's temper. A powerful solar storm could disrupt it all. It's a real threat, one that has happened before and will happen again. The sun is a dynamic, seething ball of plasma. This means more sunspots, more solar flares, and more coronal mass ejections. To grasp the challenge, we must test our defenses. Recently, experts conducted a major solar storm emergency drill. Think of it as a fire drill, but for the entire planet's infrastructure. The goal was stark, to see how our systems would cope, or fail, under the strain of a severe space weather event. This wasn't about predicting an exact date. It was about understanding our vulnerabilities. The simulation involved government agencies, utility companies, and communication providers. They faced a virtual onslaught from the sun. The drill, let's call it Helios Down, simulated a sequence of events. It began with a warning from space weather forecasters, a large, Earth-directed coronal mass ejection. Then the imaginary particles arrived. The simulation modeled widespread power grid failures. Operators in the drill had to react to cascading blackouts. They saw transformers overload and substations fail. The lights went out in simulated cities. The digital backbone of society started to crumble. It was a sobering exercise in what could be. Communication systems were another key focus. The drill simulated the loss of satellites. GPS signals vanished. Satellite television went dark. High-frequency radio, vital for aviation and emergency services, became unreliable. Even internet connectivity faced disruptions. So, what exactly is this invisible threat? What is a geomagnetic storm? It all starts with the sun. Our star is a churning mass of hot, ionized gas called plasma. Sometimes the sun's magnetic fields become twisted and stressed. They can suddenly snap and reconfigure. This releases tremendous amounts of energy in the form of a solar flare, an intense burst of radiation. Often these flares are accompanied by something even more significant, a coronal mass ejection, or CME. This is a giant cloud of solar plasma and embedded magnetic fields. This CME cloud, billions of tons of particles, travels out from the sun. It can race through space at speeds of millions of miles per hour. If Earth happens to be in its path, we're in for an event. Most of the time, Earth's magnetic field, our magnetosphere, deflects these solar winds. It's like a planetary shield protecting us. But a powerful CME can overwhelm this shield. It compresses the magnetosphere on the day side and stretches it out on the night side. This interaction is what triggers a geomagnetic storm. A geomagnetic storm is a major disturbance of Earth's magnetosphere. When the CME's magnetic field slams into ours, it transfers energy and plasma into our environment. This energy drives powerful electric currents in the magnetosphere and ionosphere. The emergency drill didn't just simulate a moderate storm, it also explored a worst-case scenario, a solar superstorm. This refers to an event on the scale of the Carrington Event of 1859. Back then, the world was far less reliant on technology. Telegraph systems failed, some even sparking and catching fire. Operators received electric shocks. Auroras were seen as far south as the Caribbean. If an event of that magnitude struck today, the consequences would be catastrophic. This is what the simulation aimed to understand. In the superstorm scenario, the simulated power grids faced an overwhelming assault. Geomagnetically induced currents surged through transmission lines. These currents can cause transformers, the workhorses of the grid, to overheat and fail. Not just one or two, but potentially hundreds across entire continents. Replacing these massive, custom-built transformers can take months, even years. The simulation showed the potential for widespread, long-duration blackouts. We're talking about weeks or months without power for vast populations. Communication systems, already fragile, would fare even worse. Satellites could be damaged by charged particles or suffer from electrical upsets. Section 5. Our Achilles heel, power grids under solar siege. Our electrical power grids are the Achilles heel of modern society. They are vast, interconnected networks spanning continents. This interconnectedness usually provides resilience, but during a major geomagnetic storm, it becomes a vulnerability. Geomagnetically induced currents, or GICs, don't respect borders. They can flow through high-voltage lines, affecting large regions. The main danger from GICs is to large power transformers. These critical components step up voltage for transmission and step it down for distribution. GICs can saturate the magnetic core, causing overheating. Sustained overheating can cause severe damage or fires. Replacing a damaged transformer is not a quick fix. Manufacturing a new one can take many months. Section 6. Whispers to static communication breakdown in a solar flare. Beyond the power grid, our ability to communicate hangs in the balance during a solar storm. So much of modern communication relies on satellites orbiting high above Earth. GPS satellites provide precise timing and location data, essential for navigation in cars, ships, and airplanes. Communication satellites relay television signals, internet data, and phone calls across the globe. These orbital assets are directly exposed to the harsh space environment. Increased radiation and charged particles from a solar storm can damage their sensitive electronics or disrupt their operations. High-frequency, or HF, radio communication is also highly susceptible. These radio waves bounce off the ionosphere, a layer of Earth's upper atmosphere, to travel long distances. This is vital for long-haul aviation, maritime shipping, and emergency services in remote areas. A geomagnetic storm dramatically disturbs the ionosphere. It can become highly energized, or its density can change unpredictably. This can cause HF radio signals to be absorbed entirely, or to scatter, rendering communication impossible or unreliable. Section 7. Eyes on the sky, scientists' blueprint for preparedness. Faced with such a daunting threat, what can we do? Scientists are not just sounding the alarm, they are also offering a blueprint for preparedness. Their recommendations focus on several key areas. First and foremost is improving our ability to see what's coming. This means deploying more eyes on the sky, advanced satellites dedicated to monitoring the sun and the space environment between the sun and Earth. These sentinels can give us earlier and more accurate warnings of potentially hazardous solar events. One crucial location for these monitoring satellites is the L1 Lagrange point. This is a spot about 1 million miles from Earth, directly between us and the sun. A satellite parked here gets a constant view of the sun and can detect CMEs as they erupt and head our way. This can provide precious lead time from many hours to a few days to prepare on Earth. We need a continuous, robust presence at L1, with backup satellites ready to take over if one fails. Investing in these space-based observatories is critical. Section 8. NASA's Vigil Recent Solar Activity and Future Flares. NASA, along with other space agencies like NOAA, maintains a constant vigil on the sun. As of May 2025, we find ourselves in solar cycle 25. This is the regular, approximately 11-year cycle of solar magnetic activity. Solar cycle 25 began in December 2019 and is currently ramping up towards its predicted maximum. This means we are seeing an increase in sunspots, solar flares, and coronal mass ejections. The sun is becoming more active, and with that, the risk of Earth-directed storms increases. In recent months, leading up to today, May 22, 2025, there have been several notable solar events. While perhaps not catastrophic, these flares and CMEs have served as reminders of the sun's power. For instance, earlier this year, a series of M-class flares erupted from a particularly active sunspot region. Section 9. The Cosmic Wake-Up Call. Embracing Preparedness. The threat of a major solar storm is a profound cosmic wake-up call. It reminds us that we live on a planet embedded in a dynamic solar system, subject to forces far beyond our control. Our sun, the source of all life on Earth, also possesses the capacity to disrupt the technological civilization we have so carefully constructed. Ignoring this reality is not an option. The warnings from scientists are clear and based on solid evidence. The potential consequences are too severe to dismiss. We must embrace preparedness. This preparedness is not just the responsibility of governments or scientists. It involves everyone. Industries need to invest in hardening their infrastructure, particularly power grids and communication networks. This means developing more resilient transformers, deploying shielding for sensitive electronics, and creating smarter grids that can better manage GIC impacts. Individuals can also prepare by having emergency kits, understanding the risks, and having contingency plans